is of roles, and then we specify the identity ID of the current user. Then I'm going to try to obtain the cached roles from my cache if they are present. So I'll say cache service get async user roles response, and then I'm going to pass in the cache key. If the cached roles are not null, then we're going to return this from this method. This means that we encountered a cache hit and I can return the cached value. Otherwise, I'm going to run the database query as normal, get the roles from the database, and then I'm going to cache this value by calling cache service set async, and I'll pass in the cache key, the roles as the value, and I'm going to leave the default values for the remaining arguments. So what you're seeing here is an implementation of the cache aside pattern, where we are first trying to access the data in the cache and returning it if it's there. Otherwise, we are fetching the data from the database and then caching it for subsequent requests. Let's do the same in the other method that's fetching the permissions. So this will be the cached key. Then I will try to get the cached permissions from my cache service. If the cache permissions aren't null, we're going to return them from this method. Otherwise, I'm going to fetch the permissions from the database, convert them into a permission hash set, and then set this value using the respective cache key. And then it's going to be available for any subsequent requests. And now that we added caching support in the authorization service, let me show you how this works. I'm going to execute the query to fetch the current user's details. And you can see that we hit the breakpoint inside of the authorization service, and we first land in the get roles for user async method. So we're going to try to fetch the cached roles from the cache, and you will see that they are not present. If I open up the Docker desktop instance for a moment, you can see the Redis container is running as expected because we configured it in our Docker Compose YAML file. So when we continue with our execution, we're going to fetch the roles from the database and set this value in the cache. I'm going to press continue, and we hit the breakpoint in the get permissions for user async method. We will also encounter a cache miss because we don't have the cached permissions. So we're going to add this value to the cache, and I will hit continue. We get back the response in Postman. And now if I send this request again, you'll see that we hit the same breakpoint, and this time we find the cached value present in Redis. If I hit continue, the same will also happen for our permissions. They will be present in the cache, and we don't have to execute an expensive database query, and we can return the response using the cached values. So this is how we can use caching to improve application performance, and I want to show you one more use case with implementing a generic caching solution for our mediator queries. I'm going to create an abstraction in the caching folder in the application layer to represent a cached query. So let me create the iCached query interface, and this interface will have two properties, the cache key and the expiration time for my cached query. This interface is just a marker interface, and it's not something that I will be able to use with Mediator, but I'm going to define a generic cached query that returns a generic T-response, and this will actually implement the iQuery interface that we defined in the messaging abstractions, and also the iCached query interface, which allows me to specify the cache key and the expiration time. It's very simple to use this interface. Let's, for example, introduce caching in the get booking query. So I will head over to the query definition, and I'm going to replace the iQuery implementation here with an iCached query implementation. So we are still returning a booking response, but I'm going to additionally define the cache key and the expiration time properties. If I specify null for the expiration time, I'm going to use the default value, and the cache key can use the booking ID property to generate a dynamic cache key value. And this is everything I have to do with my query. I don't need to change anything about the query handler implementation, which is already in place. I'm going to introduce the caching support using a pipeline behavior. So let's introduce another class here that I'm going to call the query caching behavior. This is going to be an internal and sealed class, and is going to implement the iPipeline behavior interface from Mediator. I'll specify my request and response generic arguments, and I'm going to add some generic constraints. The most important one is that the T-request has to be an iCached query implementation, and also the T-response will have to be a result. So let's add the missing members, which is just the handle method, and we're going to add the implementation in a moment. The dependencies for my pipeline behavior will be the caching service, which I'm going to use to implement the cache aside pattern, similar to what we did in the authorization service. And I'm also adding a logger to be able to log cache hits and misses. And then let me add the implementation in the handle method, and I'm going to walk you through what we are doing here. So first, I'm calling the cache service getAsync method to try to get back a T-response for this cache key. We can access the cache key property because our T-request is an iCached query implementation. And this is the reason we defined this interface in the first place. So if the cached result is not null, I'm going to log that this is a cache hit, and we're going to return the cached value. I'm also adding a structured log property containing the query name. Otherwise, I'm going to log that we encountered a cache miss, and we are just going to execute the query handler as normal. If we get a success result, only then am I going to set the value in the cache using the cache key, the result that I get back, which is a result implementation containing a wrapped value, and also I'm passing in the expiration time and the cancellation token. I need to register this pipeline behavior with mediator's request pipeline, so let's head over to the dependency injection class, and I'm going to call configuration add open behavior and specify my query caching behavior. So now I'm going to run this and show you how our query caching behavior works. I'm going to send a request to get a booking with this ID. I'm going to hit a breakpoint in my query caching behavior. So let's walk through these steps one by one. First, I'm going to try to find the cached value with this cache key. You can see the cache key value is created dynamically using the booking ID. Because the cache key value is null, I'm going to log that this is a cache miss, and I'm going to execute my query handler. Because this is a success result and we got back a result value, I'm going to set this in the cache and I will press continue. And you can see that we get a response back in Postman. If I send this request again, we're going to hit the same breakpoint, only this time I'm going to get the cached result. I'm going to log an entry that this is a cached hit, and I can return my cached result without executing my query handler and without talking to my database. And with this, we wrap up the distributed caching implementation in the Clean architecture.